Hello everyone and welcome to the channel. In today's video, we're continuing with more OSPF topics and we're still going to investigate the OSPF Hello packet. However, this time I have a completely ridiculous and unnecessary exercise for you. What do I mean by that? So the plan is to look at a OSPF packet dump from the command line and try to convert the information in hexadecimal format to decimal format so we can build the OSPF Hello packet. Again, this is just for fun for the geeks and freaks here watching my channel. You would not be expected to do anything like this in an exam or in real life for that matter, probably. I've never had to do this in my work personally, but it's still a fun exercise, hopefully. So let's get started. For the purposes of this video, I only need R1, but I also have switch 1 running in the EVNG lab so that the interface on R1 can be in the up and up state. We don't need any other routers because they will not form an adjacency anyway, since I'm going to change the parameters and completely break the entire configuration we had before. So let's go to Notepad. So here's the state that we were left with from last time. And actually a couple of specifications here, because I mentioned that I'm only running one router in this lab. There will not be any adjacencies. So that means the active neighbor field will be empty and there will be no backup designated router. So I've already put that information here. Because in the previous case when we had R1 and R2 running, R2 was the designated router and R1 was the backup designated router. Now the situation is slightly different. Okay. So now let me jump to the other tab here on Notepad, where I have another OSPF Hello packet structure, and at the bottom here I have the OSPF packet dump for the old situation that we were left with. So I've actually already changed the configuration, so I cannot show you the command line of R1 because you would see some information, and the whole purpose of this video is that you will try to figure out the information yourself. So we're just gonna have to stick with Notepad and all this previous information that I've collected here. So now let me give you a little bit of background information how I've gathered the information to the OSPF Hello packet structure from this OSPF packet dump that is at the bottom here. So this is the actual log message that you would see on the command line. And I'm actually not sure what this value is for. That's why I've put it in brackets. But this is the actual OSPF packet information that we will focus on. So now if I open up Wireshark, so here you can see a small packet capture that I've saved. And this information is identical to what we have in Notepad. So let's do a side-by-side comparison. Let me do it this way and then Notepad on the right-hand side here. And actually, if we want to see anything here, I need to adjust these because this is what we want to look at. Here is the packet contents in hexadecimal format. So you can see if I click on the fields here, it's gonna highlight them at the bottom. So that shows you what hexadecimal information is related to these fields or this part of the packet. So now by cross-referencing this information in Wireshark and comparing it to the packet dump that we have on the Notepad, we can figure out which information belongs to which field. So if I actually click on the OSPF packet here, or the OSPF section of the packet, I should say, because there's other information in this packet, like the IPv4 information and the Ethernet information, including the MAC addresses. So now if you look at the highlighted part at the bottom on Wireshark, you can see that it's very similar to the packet dump that we have in Notepad. So let me see if I can keep that highlighted. No. So right there, you can see that it's equal with this. Again, ignoring the information that is inside the brackets. I do not know what that is for. If anyone knows, let me know in the comments. So let's go back to Wireshark. And now if I click on individual fields here, like the version field, you can see that it highlights 02 in this case. So I know that those values tell me the version of OSPF for the packet. And moving along, for message types, it's 01, and for packet length, 002C, and so on. So now I have yet another tab in Notepad. Let's go to that. So here is the packet dump for the information that is currently configured on the router. And I have purposely used absurd numbers to make this as confusing and difficult as possible. So if you want to try this exercise yourself, I'll post the OSPF packet dump either in the description or in a comment, or I'll put a link somewhere so you can access this. So what we're gonna do now is pull the hexadecimal information from that OSPF packet dump and insert that into the correct field in the OSPF Hello packet structure. And we're gonna use Wireshark to help us with this exercise. So we're gonna cross-reference that information and use the existing packet capture to figure out what hexadecimal numbers go where. If you're really hardcore and want to make this exercise even more difficult, you can figure out the length of the fields in the OSPF Hello packet and then use that to pull the information from the OSPF packet dump. I'll use the easier method with the help of Wireshark. Oh, one more thing before we get started. These 0x that I've used here indicate that these are going to be hexadecimal values that follow. I had the same thing in here. That's what it meant. 0x is referring to a hexadecimal value. Okay, let's go. So back to the Wireshark. So now for the version number, right here, 02. All right, let's copy that and put it here. For the hello packet, 01. Packet length here, we have 4 hexadecimal values, so this part right here. And then for the source OSPF router, so this is the router ID. So we have 4 groups of 2, which is this section right here. Oh, I have some unnecessary information on area ID here. Let's remove that. And then click back to Wireshark. So this is going to be the next 4 double numbers here. Okay, let's copy paste it here. Then for the checksum, so I believe it's this part in the notepad or in the packet dump. Authentication I've already left to zeros because we're not using authentication in this lab. Actually, if I wanted to be really nasty, I should have included some tricks in there as well. Perhaps for next time. So let's see that in Wireshark anyway. So right here, this part would be equal to these 4 zeros. And then the authentication data, that's a big block of zeros. Let's see. So I believe it is this first block here and then the second block right here. Okay, next we have the network mask. So that would be equal to this part, like so. Then we have the hello interval value. So that would be equal to these 4 hexadecimal values. And now for the options, let's see what we have here. 1, 2 in the original Wireshark packet capture and 1, 0 over here. So let me just type it here like this. Okay. Let's see what we have next in Wireshark. Scroll down a little bit. We have the router priority. So I believe we are here in the packet dump right now, so it would be B1. And then the dead interval. It should be this block right here. Next, for the designated router, right here. And then lastly, the backup designated router. So right here, all these zeros should correspond to this block right here. Now you can see that there's still some information left here. I believe this is because of the LLC data block that's right here. Let's have a look. Yes. So we're just gonna ignore this part because we haven't talked about this before, and that's a topic for a future video maybe. So ignore the rest here. Now we've found all the information that we need and we can try to figure out what this is in decimal format. So let me close this and adjust these once more. Okay, we don't actually need Wireshark right now, so I can maximize these windows and we can focus on Notepad instead. So let's do this. So here comes the fun part. We're gonna do hexadecimal to binary to decimal conversions. Once again, this is completely unnecessary, but we're just gonna do it as an exercise. You could just as easily use a calculator to convert these directly, but to understand the relationship between these different numbers, I want to show you the binary conversion as well. And I myself actually prefer to do it that way. I can't do hexadecimal to decimal conversions directly. I have to use binary. So I'm going to demonstrate that to you. Okay, so let's start with the version field. And I'm actually going to pull out my pen tool to show this to you. It's going to be easier to explain how I do the conversions. So if we look at the version field that contains the hexadecimal value 02, this is actually equal to 8 bits. So how it works is that each of those individual hexadecimal numbers correlates to 4 bits. So let's write that down. So 1 hex is equal to 4 bits. So if we split this in 2, and we look at 0 and 2 as individual numbers and convert them to binary, we get 0, 0, 0, 0. All bits are 0, and then 0, 0, 1, 0. And that's equal to 2. Now if we convert that to a decimal number, we can ignore the leading zeros and convert only 1 0, which is equal to 2 in decimal. So the OSPF version is 2. And actually, let me copy this information to another tab so we can save the decimal information in its own OSPF Hello packet structure, and we don't have to cram the information here. So let me go away from this for a sec and then copy this information, go here, and then we'll put the decimal information right here. Okay. All right, now let's do the same with the next field. So again, let's split this like this. So we would have 0, 0, 0, 0, 0, 0, 0, 1. These are very easy. And now for the packet length, I'm not gonna write open all the leading zeros, so let's just focus on 2C. So 2 would be 0, 0, 1, 0. And for C, I need to think a little bit. I believe it would be 1, 1, 0, 0. So now if we want to find out what this is in decimal format, we need to convert 101100 to a decimal number. Now I'm gonna be a little bit lazy and I'm gonna use a calculator to help me do that. So let's go to the calculator. I need to close this first. So 101100. You can see here that it's equal to 44 in decimal. Let's open this back up. So right now we have 44. And here is going to be a tricky part. Let's see if we can figure this one out. So we have to break these down individually. So we would have 0, 0, 0, 0. E should be 1, 1, 1, 0. Then we have B, which is equal to 1, 0, 1, 1, I believe. And then 7 is 0, 1, 1, 1. Next we have D. I believe it should be 1, 1, 0, 1. And then for 9, 1, 0, 0, 1. 3 is equal to 0, 0, 1, 1. B we already had before, which should be 1, 0, 1, 1. So let's see if I've done this correctly. There may be mistakes, we'll find out. So this is the router ID. So what we can do is actually put dots in here for every 8 bits like this. Okay, now the moment of truth. Let's go back to the calculator and try to convert this to an IP address or the same format as an IP address. So here, so I think it was 0, 0. I need to delete this first. So 0, 0, 0, 0. So we can ignore the leading zeros and then 1, 1, 1, 0. That's equal to 14. So let's try to remember that, 14. And the next octet is, remove this first, 1, 0, 1, 1, 0, 1, 1, 1. So that's 183. So we have 14.183. Now let's go for the next octet. That one was 110, 11001. So that's equal to 217 in decimal right here. So 14.183.217. Let's remove this and look at the final octet. So again, ignoring the leading zeros, we have 1, 1, 1, 0, 1, 1. I believe it was like that. So 59. So 14.183.217.59. Okay, let's go back. So this should be equal to 14.183.217.59. Let's actually add this information to the packet structure before we forget this. So let's fill out those couple of fields here. So here we had 1, and then 44, and here it was 14.183.217.59. Okay, let's go back. So next up we have the area ID. Let's pull out the pen tool. I think we're going to suffer for this as well, so let's try again using the same method as before. So let's start with number 4. So that's 0, 1, 0, 0. And then we have 1, which is 0, 0, 0, 1. I'm going to include these dots here already because this is also in the same format as the OSPF router ID. So we're going to display the area ID in dotted decimal format. Okay, so the next number is 9. 1, 0, 0, 1. And then 3, 0, 1, 1. Excuse me, I did that wrong. So let me go back a little bit. It's 0, 0, 1, 1. Okay, then the next octet. So we have 1 again. So 0, 0, 0, 1. And then 7, 0, 1, 1, 1. Then again a dot here, and then we have 5. So 0, 1, 0, 1, and 1 once more, 0, 0, 0, 1. And once more, I may have made mistakes. We'll find out later how good my binary conversions are. Okay, to the calculator. So the first number was 1, 0, 0, 0, 0, 0, 1. So we have 65 in decimal. Let's remember that and go to the next one. Then we had 1, 0, 0, 1, 0, 0, 1, 1, which is equal to 147. So 65.147. Then the next number, again, I'm ignoring leading zeros, and we had 1, 0, 1, 1, 1. So that's equal to 23. So we have 65.147.23. And then the next octet, let's find out. So 1, 0, 1, 0, 0, 1. Oh, excuse me, I made a mistake here. I forgot 1, 0, so let's do it again. 1, 0, 1, 0, 0, 0, 1. Like that. So 81. So we have 65.147.23.81. So let's close this. Go back here. Let's write that down. So 65.147.23.81. Let's put that in the notepad as well. So 65.147.23.81. Okay, let's go back here. And actually the checksum and the authentication fields we can leave as is, because I believe it's shown like that in the Wireshark packet capture as well. Yeah, right here you can see that this is in hexadecimal, so we don't have to worry about that. So let's just move on to the network mask field. Okay, let's pull up the pen tool again. Now the network mask field is going to be fairly straightforward because we have F's repeated multiple times here. And F is easy to figure out because it's all ones. So what we have here is a bunch of ones like this. That would be the first F, the second F. Let's put a dot here. Then it's repeated again. The same for the second octet. The same for the third octet as well. Like so. And now for the last part, it's a little bit interesting because we have E and 0. So this is equal to 1, 1, 1, 0. That's E, and then zeros for the 0. So for the all ones field, you can probably guess that that's going to equal 255. We can prove that on the calculator as well, just for the sake of it. But let's focus on the last number. So let's go back to the calculator. So let me show you that all ones field. So that's 8 ones. You can see it's equal to 255. Now the other one we had was 1, 2, 3, and then followed by zeros. Like so. So it's 224. All right, let's put this information on here as well. So this is 255.255.255.224. Okay, then let's go back again. Pull out the pen tool. And now we're in the hello interval field. So again, I'm going to ignore the leading zeros and I'm going to focus on the last two values, B and D. So B is equal to 1011 and D is equal to 1101. Oh, I forgot to type this in here, by the way. 255, 255, 255, and then 224. All right, so let's go to the calculator to check that value. Okay, so we have 1011 and 1101. So we have 189. Let's type that here. 189. All right. So 189. Now for the next field, for the options field, we have 10. So it would be equal to 0001 and 0000. So now if we put them on here, so this is actually equal to 0. And we don't have to worry about this either. Would be better if that was 0 because we want to ignore the LLS data block. So let me just erase those two marks that I made there. And actually, we don't even have to convert that into any decimal number because it's going to be shown like that in the Wireshark packet capture. But just so you know that the E bit is 0 in our case. So let me just indicate that here by changing the values. So this would actually be set to 0. And we can do the same here. So this would be the equal value, and we can check that on Wireshark here. Like so. You can see here it's marked as a hexadecimal value. Okay, let's go back here and put it as a 0. Okay, and let's go back to the other tab. So now we have the router priority. So let's take out the pen tool. Okay, and once again, so we have B1, that's equal to 0, 1, 0, 0, and then 0, 0, 0, 1. So now we need to figure out what that is in decimal. And once again, I'm going to jump to the calculator. So 1, 0, 1, 1. And then 0, 0, 0, 1. So we have 177 in decimal. Okay, let's write that down. So 177. Okay, then let's go back here. Get out the pen tool once more. And now we have the router dead interval. Oh yeah, first let's write the conversion here. So 177 for this field. So now I'm going to ignore the leading zeros once again. And I'm going to focus on the last 3 hexadecimal values. So we have 0, 0, 0, 1. The same again. And then followed by 4. So 0, 1, 0, 0. Again, we want to find out what this is in decimal. That's a terrible arrow, but we'll leave it like that. Okay, so to the calculator. So we have 1, 0, 0, 0, 1, 0, 1, 0, 0. That's 276. Okay. 276. Then go back here. All right, so 276. All right, now we have the final field, which is the designated router. So let's try to figure that out. C is equal to 1, 1, 0, 0. And then 6, 0, 1, 1, 0. Let's put a dot here because this is going to be an IP address. Then we have 3, 3. So that is 0, 0, 1, 1, 0, 0, 1, 1. And then 6, 4, 0, 1, 1, 0, and 0, 1, 0, 0. And then finally 3E. So 0, 0, 1, 1, and 1, 1, 1, 0. Let's see if I've done that correctly. All right, to the calculator again. Let's remove this. So the first octet we have 1, 1, 0, 0, 0, 0, 1, 1, 0. Okay, that definitely cannot be correct because it's showing 390. So that's not within the IP address ranges. So let me go again. So 1, 1, 0, 0. 0110. Okay, now it looks more reasonable. So 198. Then the next octet, we can ignore the leading two zeros, so it's 110011. So that's 51. So 198.51. Then the third octet, let's get rid of this. So 011000100. So that's equal to 100. So 198.51.100, and then the final octet. So 0011110. So that's 62. So we have 198.51.100.62. Okay, let's type that. Let's go here. 198.51.100.62. Okay, so we've got through the hello packet structure, all the fields that we can complete. As I mentioned, the backup designated router field will be empty, or actually it's going to have 0.0.0.0 assigned to it because there's no backup designated router for this network segment right now. So let's just type that here. Okay. And actually, let me change one more thing in here. So just to be accurate, this is 0. And yeah, it's gonna be 10, as we've discovered. So now we have all the information ready here. So I'm gonna launch a Wireshark packet capture on the router, and then we'll see if we got this information correct. Fingers crossed. Okay, so let's go to the topology and then enable Wireshark capture here. And it might take a while for us to see the first OSPF Hello packet, because if you remember the values, that was configured quite as a high value. I think it was 189 or something. So it's gonna take 3 minutes to receive a hello packet. So let's filter this. And then we wait. Actually, while that's happening, let me enable the OSPF packet debug as well, so we can see the OSPF packet dump on the command line. Enable, so debug IP OSPF packet dump. All right, then we wait. All right, here we go. We've received something. So let me undebug all, you all. And let's see if something showed up in Wireshark packet capture. Yes, there we go. So we can actually stop this. And actually, I said it slightly wrong before. I talked about receiving OSPF Hello packets. Of course, R1 is sending OSPF Hello packets. There's nothing else on the other side, so it's not going to be receive anything. But I was speaking kind of like receiving packets to the Wireshark. So I just wanted to clarify that so there won't be any misunderstandings. Okay, so the moment of truth. Let's compare these side by side and let's find out if we got the correct information. So let's do it this way again. And then let's find the information here. All right, so OSPF header, let's see what we have here. Version 2, does that match? Yes, it does. Message type, hello packet. Indeed, it is. 1. Packet length, 44. And now here, I guess we'll find out if my binary conversions were correct. So 14.183.217.59. And right here for area ID, 65.147.23.81 seems correct. And this one we left as is, as an hexadecimal number, so that's fine. The authentication we also skipped, so let's move on. All right, here, so network mask 225.225, excuse me, 255.255.255.224. That's correct. And then for the hello interval, we have 189. That is true. For the options field, it's 10. Indeed, what we have here as well. So let me open this up. So you can see here that this E bit has gone to 0. I'll explain shortly what that means, but first let's verify the contents in the packet. So let's move down to router priority. We have 177 right here. That's also correct. And for the router dead interval, we have 276 right here. And then the designated router is 198.51.100.62. And that's a match as well. So, looks like we did a good job and we found all the correct values. If you did this on your own, did you also get the same values? If you did, let me know in the comments. And if you didn't, let me know where you went wrong and we can try to figure that out. So now let's actually look at this on the command line as well. So let me go to R1. So here you can see the packet dump that I had already copied for this exercise. And if you notice here, I left out this part because you would have seen the IP addresses and the router ID and area ID directly from this field. But now if we run show IP OSPF interface command, so let's compare this as well. Let's put this on the side. So once more, you can find out this information here. Let's go in order from the command output. So the IP address is equal to the designated router address, which is actually shown on its own line here as well. And the router ID right here is equal to this field. We have the area ID here. And then the hello and dead intervals right here. So the hello interval is here and dead interval down here. The router priority is mentioned on this line. It's equal to this value here. Oh, and the network mask right here is equal to a /27. So now let's talk about the options field. So what does it mean that the E bit and N bit are both 0? If you remember from the previous videos, it was either one or the other. So those two fields or those two bits are basically mutually exclusive. So if you have an NSSA area, meaning that this bit is set to 1, if we change it, then the E bit has to be 0 and vice versa. So if the router has external routing capability, meaning that this bit is set to 1, then it cannot be an NSSA area. But what about when both of those bits are set to 0, which is our case right now? Well, that means the router is actually, or the area is a stub area. So we haven't really talked about the stub area or OSPF area types in general, and I'm not going to go into detail about that right now. But just so you understand, this is how it is identified at the packet level. So if I go back to router 1, I can issue this command show IP OSPF. And let's see the line that I'm looking for right here. So you can see 0 normal areas, 1 stub area, and 0 NSSA. So you can see we have 1 stub area here, which is why the bits are marked as they are in the options field. So both NSSA, the N bit, and the external routing capability, the E bit, are set to 0. That then indicates that this is a stub area. I can show you this from the running configuration as well. So if I do show run and then section router OSPF. So you can see what I've configured here. This area, this crazy area ID, is defined as a stub area. And we can also look at the interface configuration as well. So if I do show run interface and then gig 0/0. So you can see all the absurd values that I've configured here. Okay, so that was a full brain dump of information. I hope you enjoyed this video. I hope it was fun to see the hexadecimal to binary to decimal conversions. I understand this video was pretty packed with a lot of information and possibly a lot to chew. So if you made it this far, let me know in the comments and share your thoughts if you like this kind of crazy videos sometimes. With that said, thank you so much for sticking around and watching the video, and I'll see you next time.